Hello everyone. The topic of the discussion is mathematical models for the communication channels. Communication channels. In order to do the mathematical representation of this, what do we need to know? For example, when we are transmitting the radio signals, or now suppose we are transmitting them through the air sub. Another kind of example is telephones. There we have the physical channels. We also have discussed the underwater communication channel. So in case of the underwater communication channels, the wave transmission is different. How it is different? Now, for example, I'll take the two cases. One is cellular radio channels. That is nothing but whatever the cell phone signals transmitted. That is one. Another one is telephone channels, wired telephone channels. Now look into these two. We just identify what are the differences in that. Then it is easy for us to go for the mathematical modeling. Initially, I'll take the telephone channels. So, in case of the telephone channels, multiple user signals are transmitted over the telephone channels in the form of electrical signals. And since multiple user information is transmitted, the information has to be separated from one another. Next, if you take the radio channels, the case is different. There the bandwidth is allocated and they are transmitted free over the media. Next is, in case of the telephone channels, the wire they are transmitted through a physical wire. Now in the case of the radio channels, cellular radio channels, their signals are transmitted through ionosphere. In the ionospheric transmission of these signals is characterized by multi-path wave propagation. What is multipath wave propagation? It's nothing but signal that is transmitted from the transmitter in case of radio channel follows different paths. It gets reflected by the ionosphere and reaches the receiver. When the signals are getting reflected, they follow multiple paths, and each of these signals get collected at the receiver at different time instants following different paths. That is what is multipath wave propagation. So, multipath wave propagation is the characteristic feature of cellular radio channels. Now, just look into these two. These are the two differences that we quoted. How do we go for the mathematical modeling of this? So, as we are seeing here, their behavior changes with the time, and one is another is with respect to the time they are propagating, their behavior remains same. Therefore, only in the main classification, these channels are taken as a time variant and time invariant. In the basics of the signals and systems, we have come under, we have studied that concept time variant and time invariant. One which changes its behavior with respect to the time is time variant. One whose behavior does not changes with respect to the time is time invariant. So, the mathematical model for communication channels, we study three types. Two are of time invariant and one is for the time variant. We look into those two with the examples. To begin with, the additive noise channel. The signals that are at the receiver through different paths reach at a different time instance. That is the time variant type. Now, initially, we'll go for the additive noise channel. The information during its journey it passes through this physical channel which we call as the communication channel. During its journey it gets added with the noise. As we are saying here, getting added with the noise, mathematically we represent this, that is signal s of t getting added with the noise n of t when it is transmitted over the channel. This happens when the channel is noisy. The additive noise over the channel, it arises due to the electronic components and also the amplifiers that are present at the receiver. Therefore, this is called additive noise. And the signal that is transmitted gets attenuated, so we consider the attenuation factor as well. So the alpha is the attenuation factor, then the received signal R of t is equal to sum of transmitted signal S of t plus the noise signal N of t. Along with that, the signal S of t is getting attenuated by the attenuation factor alpha. So the block diagram is represented here and the equation. This is in the case of additive noise channel, the noise in the physical channel is introduced due to the electronic components and amplifiers as said. This noise is characterized by the thermal noise. It is statistically represented using the Gaussian noise process. The channel is, hence we call that as the additive Gaussian noise channel. And additive Gaussian noise channel is nothing but an additive noise channel itself, but the noise added is a Gaussian noise. Now moving on to the second one, that is linear filter channel. The linear filter channel, this is also a time invariant channel. This is to characterize mainly the wireline telephone channels. The wireline telephone channels, they carry the multiple signals and these signals are band limited. In order to get the band limited signals, filters are used. These filters ensure the signals are band limited. And also, the purpose of going for the band limited signals is, since multiple signals, multiple source signals are transmitted over this telephone channel, is it? These do not get interfered. So for that reason, we are band limiting them. See, for example, now over a channel, you have the multiple signals transmitted, means from source 1, source 2, source 3, source 4, like that. And how do we ensure these different four source signals do not get interfere when it is transmitted over the channel? To ensure that, we band limit them. So this band limit is done using the filter, and that is a linear filter. So the signal S of t pass through the linear filter to ensure the band limitation, and then when it is transmitted over the channel, it is getting added with the noise. Therefore, with the block diagram representation includes S of t passing through the linear filter. This linear filter, if you observe the block diagram, the linear filter is represented by C of t. C of t represents the impulse response of the linear filter. Impulse response of the linear filter. Then the output of the linear filter is given to an adder. The inputs to the adder are output of the linear filter and also the noise N of t. So here the thing to be observed is linear filter mathematical equation. If you observe, the output signal R of t is convolution of S of t with the impulse response of the linear filter C of t plus N of t. Let me clear one thing. Convolution always characterize it represents the signal S of t passing through the linear filter C of t. So this is represented by using the convolution. Therefore only the equation. If you write it in the expanded form, you can observe here the convolution is expanded CO of 2 S of t minus 2 d2 plus N of t. The filtering of the discrete time signals using FIR digital filters is represented using convolution. So only here S of t pass through linear filter, as we say. Mathematically it is represented by the convolution. So linear convolution represents discrete time signals through the FIR digital filters. Now last one is the linear time variant filter channel. The As I said, the ionospheric radio channels and also these underwater acoustic channels transmit the signals using multipath signal propagation, and these signals at the receiver come through the different paths, reach at different time instants. Hence, only the name, that is time variant filters. The signal transmission over these physical channels are characterized by the time variant linear filter. So, only with respect to the second one, in case of this, the main difference is linear time variant filter is used. C of tau with respect to t. The time variant channel impulse response, how, in the previous case it was a time invariant channel, it was a impulse response of the linear filter. Now it is impulse response of the time variant filter, represented as C of tau with the t. It's represented as the response of the channel at time t due to an impulse applied at time t minus tau. Tau is the age variable. Now, I need to understand at different time instants, at multiple paths, we need to consider in the equation form. So, if you observe here, not only the C of t, it is also considered tau with respect to t into S of t minus tau d tau plus n of t, where this C of tau with respect to t means the impulse response of the filter at the time instant tau is equal to summation k ranging from 1 to L ak of t delta of t minus tau k. Why do we consider this? Because there are k different multipath propagation. So k paths are there, L paths are there in total, and each considering k ranging from 1 to L. So the attenuation factor is nothing but ak of t. For one particular path, ak of t is the attenuation factor, that is multiplied with the impulse response. This is how we get the impulse response of the time variant filter. So this is all about the mathematical modeling of the channels. Three different types are there. Thank you.